So now with rational, instead of rational expressions where there's no equal sign, we're going to throw in an equal sign and solve some rational equations. I'm going to start with one that hopefully we already know how to do. Let's say we have 4 over x, and that's a rational expression, but if we said that equal to 6 over x plus 3. Now, here is where we have just one rational expression equal to one rational expression, just one term on each side. So we should already know how to do these by cross multiplying. Okay, so we did this back with ratios and proportions. With proportions, if it's just a fraction equal to a fraction, cross multiply. So we would have 4 times x plus 3 equals 6x. Now, before we keep going, the one thing that's different now is we need to think about what x cannot equal. In this case, in the first fraction, x could not equal 0, and then in the second one, x could not equal -3, because then we'd get a 0 on the bottom. So we'll always note that, and then we'll talk about, well, what happens if we get that to be an answer. So let's keep going with this one. 4x plus 12 equals 6x. Subtract 4x on both sides. 12 equals 2x. Divide by 2. And x equals 6. Which if I plug it back in, it looks like it would check out. I'd get, we'll check here, 4/6, which would be 2/3 on the left side. And then on the right side, I'd have 6 over 9, which is also 2/3. So I got the right answer, and I can plug it in, and nothing's undefined, so I get 6 being my one answer. Now, let's look at another example. And I'm going to leave space for 2 lines for a definition, and then I'm going to put up the first example, and we'll talk about what's different about it. So the next one, let's do 2 over x plus 1/2 equals 5 over x. Okay, with this one, now it's a little different because I have 2 terms on the left side. So I can't do any cross multiplying because of that plus. So when it becomes more complicated than just a proportion, what we do is we multiply both sides, of the equation, and I'm going to put in parentheses every term. We have to make sure we do every term. Multiply both sides of the equation by the least common denominator. And really, I mean, you could think of it like least common denominator over 1. And then solve like we normally would. And we've done this before. When we have lots of fractions, we've multiplied by the least common denominator to drop out all those bottoms and solve from there. But the difference now is there's going to be x's on the bottom. Before, it was all just numbers on the bottom. Okay, so for this first one, before we get going on this, let's note what can x not equal. X cannot equal, the only thing would be 0. So because of the 2 over x and the 5 over x, x cannot equal 0. So if I look at my denominators, x and 2, 2x would be my common denominator. So I'm going to do 2x over 1 times 2 over x plus 2x over 1 times 1/2 equals 2x over 1 times 5 over x. Okay, so let's see what's going to drop out. So in my first one, the x's drop out. 2 times 2 is 4. Next one, 2's cancel. I'm just left with x times 1, so x. Last one, x cancels. I'm left with 10. And just have one step here. Subtract 4. X equals 6. Okay, so if I plug it in, check my answer, it should work out. Well, you can trust me on this one. X equals 6 would be my answer. Think about, it's not 0, so it's okay. Okay, how about, okay, let's do do one more. So, my first fraction, 3x over 3x minus 1 plus 1 over x equals 1 over 3x minus 1. So, before we do anything, let's note what x cannot equal. X cannot equal, well, 0, because of that 1 over x. Now, the other part, if you want to, jot over to the side. When is 3x minus 1 0? I'd add 1 to both sides, divide by 3, so x cannot equal 1/3 as well. So x cannot be 0 and x cannot be 1/3. Okay, so now I'm going to look and figure out, well, what's my least common denominator going to be? So I need a 3x minus 1, and I need an x. And that'll take care of all my denominators. So I'm going to multiply that over 1 by each term. X, 3x minus 1 over 1. Oops, leave a little room here. So 3x over 3x minus 1. Bring down my 1 over x. Squishing a little here. And then x, 3x minus 1 over 1 times 1 over 3x minus 1. Okay, so every term, let me double check, I did 3. 3 terms in the whole equation, 3 times I'm multiplying by x, 3x minus 1. So 3x minus 1 cancels in the first one. I'd be left with 3x squared. Get my color right. 3x squared. Plus, x is canceled, so I'm left with 3x minus 1 equals 3x minus 1 cancels. I'm left with x. Okay, now this one's a little different because I have an x squared here, so I'm going to have to solve this like a quadratic equation. So I want to set one side equal to 0. So I'll subtract x. 3x squared plus 2x minus 1 equals 0. Try to factor. 3x and x has to be 1 and 1. So now I'm going to have a plus and a minus, but I want my bigger one to end up being plus. So 3x minus 1, x plus 1. That's how I'd be able to factor that. Okay, so now if I set them each equal to 0, so add 1 to both sides, divide by 3, and I get x equals 1/3. But then I also get x equals -1. So I actually get 2 answers here, which happens with quite a few of these. You could end up with 2 answers if we had ended up with an x squared once we drop out the bottom. So now let's go back and think about if I plug this in though. Remember what we said? X cannot equal 1/3, because if I go back and I plug in my first answer of x equals 1/3, if I plug it back into the equation, I'm going to get 0 on the bottom, which is undefined. So x cannot be 1/3. This part is undefined. So my only answer is x equals -1. Now that, if I plug that in, -1 back into the original equation, it should work out. So I only get one answer. Now if my only answer had been the 1/3, then we would have no solution. So that can happen sometimes if you only get one x and it was supposed to be undefined, then there's no solution.